So can you tell us a little bit about Planetary Resources, what the company does, and what your goals are?
Absolutely. So Planetary Resources is a space resource company. The idea that we have and what we're pursuing is opening up space in a way that's different how our government has been exploring space, and maybe more like how we have gone into frontiers here on this planet. And we think that in order to do that, the best way is to use the resources of space to help explore space. And our goal is to expand the economic sphere of influence of the planet and expand that into the solar system. We have, of course, a great economy here on Earth. That economy actually extends out into space on the geostationary belt, but we want to go out into space and go even further. We believe the asteroids, the near-Earth asteroids in particular, are the way to achieve that. So we've been focused on creating technology, using all the advancements that we have seen very recently to take this type of exploration, build on what NASA has done, build on what other space agencies have done, and use that as a private effort to be a space exploration company. So in Seattle, we're working on technology. We have a lot of ex-NASA engineers like myself. We have people from the microelectronics industry, automotive industry, even interested in people in the medical industry. In many ways, a lot of the advancements that we're experiencing are coming out of these other fields, not just aerospace. So we want to take all those advancements and apply them to space. So I guess in doing this, I want to explain a little bit of the challenge of space exploration. Earth has been a fantastic home to us, a great place to get started, and will be so for hopefully forever until the sun burns out. Yeah. But it's so big that we can just barely get off of it. And I've got a short video which really helps explain that challenge and how that by using space resources, once we're off the Earth, we can really use those resources to do anything else. So why don't we roll that quick introductory video?
Okay.
Imagine that you're on a road trip from Seattle to New York City. Now, what if there were no gas stations along the way, and you had to bring all the fuel that you'd ever need with you? You'd have no room left for anything. Well, in outer space, the problem is even worse than this. After all, judging by the space race of the 60s and 70s, you might have thought we'd have colonized Mars by now. But we haven't. We're trapped at the bottom of Earth's gravity well, which is so deep that escaping the first 300 kilometers takes more energy than the next 300 million. It takes 50 kilos of propellant to deliver just 1 kilo to Leo. But 4 more would get you the next 35,000 kilometers, and 2 more, the last 300 million to Mars, to the asteroids, to anywhere in the inner solar system. But those 4 kilos to Geo each need 50 kilos to get into Leo first. And those 2 to everywhere else each need 4, which each need 50. This exponential nature of the rocket equation has us stuck hugging our planet. Planetary Resources has had a Copernican shift in thinking. Travel beyond Earth's gravity well is nearly effortless. So, if fuel is sourced from space for space, we can avoid this exponential problem altogether. Fortunately, rockets run most efficiently on hydrogen and oxygen, which is just electrolyzed water and exists in near infinite quantities on asteroids. These future oil fields of space are also ultra-high-grade precious metal mines that lie unperturbed as the low-hanging fruit of our solar system, energetically closer than the moon, just waiting to be harvested. Mining asteroids could provide a fuel source 1,000 times more efficient than the brute force bring everything with you approach used by the Apollo moon program. So how big is the space market when economics improve by 1,000 times? No one knows for sure. But neither did the Wright brothers at Kitty Hawk, nor IBM or Bill Gates at the dawn of their new markets.
So this is the big idea. That all of the energy, all the resources that we actually need to explore space, to set up permanent outposts in space and live and work there indefinitely, are already out there on near-Earth asteroids. In fact, in the last 15 years, we've discovered 95% of the asteroids that have ever been discovered, but we're only 1% done for everything that's out there. And as an engineer, the most interesting fact about this is that there are asteroids called near-Earth asteroids, and as you would expect, they're relatively near to the Earth, energetically speaking. And 5,000 of these near-Earth asteroids that I can give you a name and location for today are actually easier to get to and bring materials back from than it is to land on the surface of the moon and do the same thing. And we've done that 6 times already. So that's the goal of Planetary Resources. We're launching hardware into space next year. We'll be off to the asteroids in a few more years, and kind of look forward to creating the space economy.
Okay. Well, I'll get back to you on that. Michael, of course, you're actually interested in going to the moon. So can you talk a little bit about what Liftport is doing these days?
Sure. We started out as a NASA research team almost over 10 years ago. We went and focused on building an elevator on the Earth for a long time, and frankly, it was a mistake. I still believe that Earth elevator is definitely doable eventually, but we can't do it yet. The technology just isn't there. So about a year ago, we shifted gears to focus on the moon. We had several breakthroughs just in the way that we thought about the problem. And Chris is right, getting onto the moon is incredibly complicated. You saw the video with the rocketry. The amount of fuel to soft land anything on the moon is extraordinary. So what we looked at was, let's build an elevator on the moon. Instead of trying to soft land on the moon, we would actually get to the Lagrange point. That's the balance point between the Earth and the moon's gravity. And then take an elevator down that last bit. I mean, it's still 55,000 kilometers. It's, it's still long, but that simplifies the effort of getting to the moon, and at the same time, it builds a permanent space station at the Lagrange point that can be used for all sorts of other applications. I'm a big fan of going to asteroids. I'm a big fan of going to Mars, and by establishing what I refer to as a beachhead at this picogravity lab, the Lagrange point, we have access to the entire solar system. So the hard part is still hard. You still have to get there, but once you do, it opens up the rest of the solar system.
I see. So what kind of things, can you talk a little bit more about the breakthroughs that have allowed you to, because literally the technology exists right now to be able to build a space elevator to do this, right? It's just a matter of having the money to build it and doing it, right?
Yeah, absolutely. And we're actively fundraising starting next year, so I'm glad you brought that up. Okay. January. Okay. But it's true, the materials are there, the technology is there, robotics, the communications, all of that exists. We just have to start putting the parts together. And our team have spent really this last year laying the foundation, double checking our math, bringing in an extraordinary board of advisors to start setting everything in place. Okay. This year has really been about understanding the problem, asking the right questions, identifying the questions. Right. We're not trying to get answers yet. We're not there. It's still trying to organize the problem. Okay. That really happens next year. So we've got a 2-year research phase starting in the beginning of next year. And then it's all about bending metal and building stuff. Okay. So yeah, that's our process.
Okay. Yeah, I'd like to answer that question too, sure. Actually. Like with any breakthrough that happens in technology and progress, it's a confluence of a number of things. As I had mentioned, we're building on what NASA has been doing for 50 years now. We've sent missions to asteroids before. We even bring samples back from them. But today, with everything that's going on, the tools that we have available, the experience that we have, the hardware that's available to use, small teams can now do what it once took governments to do. A great example of that is Burt Rutan and his team at Scaled Composites won the Ansari X Prize with 30 people and about $30 million by Paul Allen. And they were able to do what took the Soviet Union and the entire United States government to do in the early 60s. They did in a few years in a small shop with a bunch of guys. So this type of progress is enabled just from the pace of technology. From a funding standpoint, We have a lot of very wealthy entrepreneurs. Planetary Resources is fortunate to be supported by a number of visionary, very wealthy people. But that wouldn't have been possible 20 years ago because one, it would have been too expensive, and people who were inspired by the Apollo program hadn't quite made their billions yet.
Right.
And then last, we've learned so much about our solar system. We've learned so much about asteroids that we can say with confidence that the resources that we're after are out there. And we've got thousands of targets to pick from. So, now it's never been a better time. We hope that it is time and we're not 5 years too soon.
Right.
But like all things, everything happens by working at it, and that's what we're doing.
I see. And I know that there are, of course, lots of wealthy investors out there, but both of you actually kind of took the crowdfunding route. So I would kind of like to hear your thoughts on how that went for you, maybe if there's things you would have done different, and just what the experience is it's been like to have kickstarting basically space projects. That's kind of a new thing, right?
It was really interesting. We were the very first $100,000 space campaign. And frankly, we had a lot of challenges. It's been a year. We still don't have all of our T-shirts out. We have our T-shirts, but we don't have them all out. It was actually really complicated for us. We didn't really know what we were doing. Yeah. It's funny. We take some heat for this because here we are trying to build an elevator on the moon. We think we know how to do that, but getting cards and T-shirts and stuff like that out was completely new to us. So there was a lot of stumbling along the way there. But honestly, I was telling Chris earlier, it literally changed our lives. 100,000. We asked for $8,000 and we got 110,000. So completely unprepared for that. Our company was shut down. We were completely shut down in 2007 because the project basically ran out of cash, and the Earth elevator was infeasible. So we literally had to start from zero, less than zero, just to get the Kickstarter going. And then all of a sudden, we're like, hey, you used to work with us, and you used to work with us, and you used to work with us. All of you guys have day jobs now. Do you want to come over and volunteer to start putting some of these parts together? Very, very complicated, logistically complicated. Not technologically, but logistically challenging. But it did. It gave us global visibility to what we considered a brand new idea. The lunar elevator has been envisioned. I'm 46. I was 2 when it was invented. Okay. We went to Jerome Pearson, the guy who actually invented it. Jerome Pearson taught Arthur C. Clarke how to build a space elevator for his books. So Pearson's been around for a while, and we talked to him. We got a bunch of folks involved. But the process of just taking what was a research paper and turning it into a thing that exists in the world was very complicated. Yep. Yeah, but the Kickstarter folks have been amazing. We wouldn't be sitting here otherwise.
I got you. Yeah. And Chris, what was your experience with Kickstarter?
Yeah, for Planetary Resources, I would say our experience was parts typical and parts very not typical. There were aspects of it where, unlike Michael, we had a full team who'd been working on our Orchid spacecraft. And had more to draw on, but it shut us down just as much. It is an incredible undertaking, and all of the best run campaigns, we talk to folks from all sorts of different projects. It's a full body commitment. Yeah. 24 hours a day, 7 days a week, not only for the duration of the entire project, but probably for a month before to get everything set up. We set a very ambitious goal. Our minimum raise in Kickstarter was $1 million, because we were talking about funding an aspect of what we're doing. But for us, it wasn't as much about the raise, it was about answering a question. And the experiment was, as a privately funded space exploration company, is the public interested in what we're doing? should we invest some of our resources in sharing what we're doing with everyone who's very interested? And we had the idea to do this because when we announced our company to the public last year, we had an overwhelming response of interest. We had, within the first 24 hours, we had over 1,000 job applications. We had thousands of people ready to invest. We had tens of thousands of people signing up to email lists. We were on the Daily Show the day after we announced it. It was just a sensation. And everyone was kind of wanting to help, wanting to get involved, kind of wanting more. So with our Kickstarter, we put out a few ideas for that, not knowing what was successful, and it was very successful. We raised $1.5 million, started a few new projects, and now have a community to start with of 18,000 people. Yeah. And we have gotten all our t-shirts out, but it was a lot of work. Yeah. But we have a lot more to do. It is something that certainly can be enabling to people getting started in any project, but you've got to take it with kind of your full attention to really make it great.
I want to amplify on that. You know, one of the things that was startling to me, everybody focuses on the money, right? Kickstarter's about money, 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 raise money. No. That is the furthest thing. Yes, it's a factor, but the thing that's actually most important, I think, was the contacts and the relationships and the global community. We have sourced that. I went through and I identified most of the folks, you know, their Twitter accounts, their Facebook accounts, whatever. And some of these people are pretty amazing. And some of them we've asked on our board of advisors, you know, PhDs, members of parliament. I mean, just some very interesting, influential people, name brands in the Silicon Valley community. Some of these people are really interested in what's going on. Yeah. Beyond the t-shirt aspect of it, which is what everybody focuses on, the connections and the relationships that you build with those people are very, very important. It's real. I believe that I said we were only looking for $8,000. I didn't really care about the cash. I was really trying to build the community, and I wound up with a community much greater and much better than I ever anticipated. So that was really the payoff for us.
So generally speaking, I mean, you know, I know it's been maybe a bigger commitment than you first initially thought when you did it, but is this something like, if we've got anyone in the audience out here that wants to start a space startup, like, do you recommend Kickstarter? Is that the way to go?
There's no better way to test your idea and see if people are truly interested in it. A market survey that is where you check in the box and then send cash certainly demonstrates that people have a strong interest and that you've hit on something. And ultimately, with everything that is on the various crowdfunding sites, it's all about market test, and it's about creating a business and doing something that it's of value to people, whether that's value as a service, as a product, or as an idea. And being able to communicate that idea really finds, you know, where your supporters are, people who want to come to the cause to help, and if not, you only put 30 days into it. You know, for us, failure was an option. We would have been perfectly happy to have run the campaign and for it to be a complete dud, because then we go, oh, it's really great that we didn't, you know, waste any more time doing that. And it's, you know, the Silicon Valley mantra: fail early, fail often. You know, I think with Kickstarter, if you got an idea, put it together, get a good video. You know, certainly you have to connect with the people who are going to get the job done when you're expressing that. But do it sooner rather than later.
It's really important to have a community that you can tap into. We've seen other folks try to build space-related campaigns, Indiegogo and Kickstarter, and they've been kind of catastrophes. So being able to connect with a community is very, very important. And we both had that. You had it because of your press release and the announcement when you guys started the company. We'd been working on the elevator for 10 years, and we had a pretty extensive newsletter list and message boards and communities. So we already had folks that we could tap into. So that was a kind of important distinction.
Very cool. So kind of shifting gears here, you're both in the private sector now, but you know, Michael, you worked with NASA. Of course, you worked for NASA for quite a while. Can you talk a little bit about the pluses and minuses of public versus private and trying to do these things, space exploration, in the context of working with a governmental entity like NASA versus what you're doing now? So, Michael, what has it been like for you?
For me, my experience with NASA has always been on the edges. I was a contractor for the Institute for Advanced Concepts research team. I got brought in, I'm not an engineer, I got brought in because of my background in business, operations, management, marketing. They were trying to say, okay, we think we know how to build an elevator to space. Let's look at what I refer to as the fuzzy problems of doing that. What's the international policy questions related to stuff like that? Right. So I was always on the edges of NASA, not actually in it. It's a very interesting culture from the outside. A lot of my friends work there. I think it's a great organization. I don't really fit.
Okay. Yeah.
Yeah.
Fair enough.
Yeah.
And Chris?
Yeah, for myself, probably since 8th grade, I wanted to work for NASA to build spaceships that go out into the solar system. And I started as a system engineer at the Jet Propulsion Laboratory in Pasadena, and that carried through to the once in a lifetime opportunity to do what Mohawk Guy is doing now. I was a flight director for Spirit and Opportunity and mission manager on the Mars Phoenix lander, and it's a different environment. You've got taxpayer dollars that are funding what you're doing. You've got decades or more of peer-reviewed science and a lot of very thorough consideration. And to some extent, it's gotten to the point where failure is not an option. And when failure is not an option, success gets really expensive. And these are why a lot of these government-funded missions cost a lot of money, and for good reasons. You want to make sure that it can be done right. You've got all this experience and all this infrastructure and all this know-how, so you can apply all that to do things like the Curiosity Mars rover. Right. Extraordinarily complex, but extremely capable, and of course, when executed well, it's fantastic. A private company would never be able to do something like Curiosity. Nope. This is where it's a little bit different. Moving from the publicly funded activity to privately funded activity, it's not that we necessarily have more risk in what we're doing, but we kind of have a different way we can do it. I don't have to carry along with me 50 years of baggage of procedure and policy and infrastructure and opinions. I can now look to innovation that's happening all around the world, and I say, I want to use this that's happening in the microelectronics industry. I want to use these cloud computing technologies that have evolved in the past 3 years. I want to use this new chip that's just come out in the last year. And there's all risk that's associated with doing that, but without taking the risk, there's no reward. Right. So each has its place. Each are extraordinarily challenging for different reasons. The grass is not greener on either side of that fence, but I'm thoroughly enjoying the entrepreneurial aspect of it, and really, in this community aspect too. It's been more fun as well as an individual, not having a bunch of handlers and press and administrators between the company and the people who are really excited about what we're doing, and coming out at events like this and just sharing the excitement of the wonderful opportunity that we get to do to try and do something new.
I gotcha. And so I'm here, is the main kind of advantage to being in private is just kind of the speed and the freedom to do what you think is going to solve the problems you have best? Is that fair?
Yeah, I think so. You get to make the decisions right or wrong. Okay. I spent several years going down a rabbit hole with the Earth elevator. I lost several $1 million out of my own checkbook, right? That was a big mistake. Right. So one of the advantages of working in a NASA environment is, barring a shutdown, you get a paycheck, right? So, so you take on your own risk. You take on, I believed what I believed, I thought what I thought, I made a decision, it was wrong. But had that happened in a NASA environment, there probably would have been some more checks and balances. Yep. I think we might have even gotten to the same conclusion. I mean, a lot of smart people thought something was wrong. Right. And there's still folks in the elevator community that think we should focus on the Earth system, focus on the materials, and have a Manhattan-style program focused on carbon nanotubes that will eventually get the Earth elevator built. So I've actually kind of veered away from the primary community by carving out this path towards the moon. But that's a risk. I mean, I'm willing to take that risk. That's my choice. It's my decision, and I'll stand or fall based on it.
Yeah.
You don't have that luxury. I mean, sure, you had the ideas that you wanted to move forward and couldn't.
You have to put them up to a review board.
And if it was, you know what, I don't care what the review board says. They're like, fine, there's the door.
You'll
right?
be politely asked to go somewhere else.
Right.
Yeah, I was in the Marine Corps for a long time, and I got meritoriously promoted, but I almost lost that stripe from insubordination. So I kind of go both ways.
Yeah. Well, in the private sector, sometimes insubordination is rewarded.
Yeah.
But yeah, the flexibility of just being able to make a decision and then the responsibility of having to own it.
Yep.
But the nice thing is if you make a poor decision, you can correct it sometimes just as quickly. You know, I think too, from a private sector standpoint, you have a singular focus of the goal that the company was founded to do, and you know, maybe you modify that goal as time goes on, but you create the organization, you pursue that with the tools that you have, you bring people into your team to enable that, and you are focused on that one goal. You don't have all these other institutional things you're worried about and funding cycles, you know, that's going on, and congressional districts and you know, other longer term mandates. I think, you know, as capitalism as an economic theory, you know, the best ideas win, and it's all about the efficiency of being able to pursue them. If you've got a bad idea, you know, it will play itself out. Yeah, if you've got a good idea, you know, it's all about execution and getting it done. And it's an environment where I think really the best ideas win. And what's great about it is, and especially the way that we're pursuing this, it has to sustain itself.
Right.
You know, it's a business. You have to pay for your costs. You have to make your shareholders happy. So you're really focused on, as efficiently as possible, meeting those goals.
I see.
That's an interesting distinction. We've got this great big goal that's several years out, but we're actually spinning off technology already.
Yeah.
Like our IP is the thing that actually keeps us in business. The IP is the actual business behind the business.
Yeah.
Because we're not going to have our lunar elevator built for about 7 or 8 years, or 6 or 7 years. But we've already had breakthroughs in materials. We've already had breakthroughs in computing and robotics.
Yeah.
We're spinning that stuff out already. We spun the first one out just a few weeks ago, and we've got another one that'll spin formally in January. And that's tangible businesses that have value down here on Earth that have nothing whatsoever to do with space, but are incremental technologies that lead us towards our end goal.
Yeah, I would echo that exactly. You know, mining asteroids, recovering resources from asteroids will take a while.
Yeah.
And while we're working on it, what's wonderful is we've got a set of constraints. We've got innovation that's happening within those constraints because of the challenge that we have to pursue, whether it's space elevators or mining asteroids. There's some problems to solve. Yep. And in the course of solving those problems, there's IP that you create, there's work that we're doing that's of value to NASA, where it originally came from, or of value to the Defense Department, for example, or even private business aspects of it. And that's the kind of the aspect that just focuses you on doing something that's useful to other people.
I got you. Okay, well, now we've gotten a few questions from the audience. I'd like to go ahead and pose those if we could. First question is there any collaboration with NASA, which is currently developing the Orion program, which has a goal of getting astronauts to an asteroid in the future? So I guess that's a question best served by Chris.
Yeah, absolutely. NASA's stated goal is to send a human to an asteroid by the year 2025, and they've been exploring the best way to do that. We've been working with them, of course, and trying to guide, from an industry standpoint, what can be done for the use of resources and the infrastructure that can be created in the process of these public-private partnerships. You know, it's often the case the government lays in the railroad, but all these other activities now can leverage that railroad to do other things along the way. And in space, this is a wonderful role for government activity to play. Along the way, we've been doing things with our technology. We're using optical communication with lasers on a very small platform, and we've actually been under contract with that work, and also working on optimization of navigating to asteroids. So that type of collaboration is taking place, and we're talking with NASA all the time. I'm speaking at an event in another 2 weeks about ideas for how to make this asteroid initiative work.
Okay, very cool. So next question. People are very excited about the idea of space exploration generally. Besides crowdsourced funding, what other things can ordinary citizens do to help you achieve your goals?
Oh, I want that one. Sorry.
Yeah. I have one as well, so you start.
So we have been tapping into our Kickstarter community for expertise, but it's not all, as the phrase is, rocket science, right? You know, we've tapped our folks for art, imagery, marketing, law, international policy. Honestly, there's so many things that our entire community, and not just our companies, but the whole space community is really desperate for folks to just help out. Whether it's a research problem or a technical problem or a really mundane thing, helping me figure out, somebody had to help me figure out how to make t-shirts. I mean, I actually needed that help. I'm embarrassed to say that, but it is true. So there's a lot of really mundane tasks that all the space communities, and there's probably a dozen commercial space companies that are really seriously credible companies out there, a dozen, maybe 20, right? And they're all struggling with these same problems. So that's a very general answer because we have some very general problems.
Yeah.
Does that make sense?
Yeah, so you're saying there's an opportunity for someone to build a t-shirt building startup?
Yeah, well, yes. But it's operations, it's logistics, it's law, it's policy, it's accounting, it's you know, it's standard mundane stuff that has a space application.
And the problems are, is it fair to say that those kinds of issues are faced by everyone? These are common threads?
Yeah, I would
for the
think
most
so.
part?
I'm not a particularly good writer. Actually, one of your Engadget folks helped me with a technical paper that I put together, and I wrote up 85% of it, and he helped correct it, and I submitted that to the National Research Council.
Yeah.
You know, so I've been crowdsourcing from our community since really the beginning. Yeah, there's a lot of things.
I got you.
Yeah, so I've got a great specific technical example, and as Michael said, there's opportunities for people of all disciplines to get involved. It's not just engineers and scientists and of a technical mindset. It's about accomplishing these things. One of the things that we've been developing over time is the idea of citizen science and crowdsourcing some of our analysis and technology development. And this is the idea that today, one of the tools that we have available is the ability to communicate with anyone on the planet. And as Larry Ellison had famously said, the smartest people in the world are probably working for someone else. But now what we have the opportunity is to tap into their interest, their intrigue, their inspiration in what we're doing, and we're going to use that as a first project in Planetary Resources early next spring when we release a project in collaboration with the Zooniverse. We're going to create the Asteroid Zoo.
That's cool.
And we're going to take 15 million images from the Catalina Sky Survey, the most prolific discoverer of asteroids on the planet. But the thing is, we probably haven't found all the data that's in that data set. So we're going to create a zoo where people can actually go through and review this data and find the asteroids that are in there, and also find the things that confuse the computer algorithms that originally did that process. And then through data challenges and other things and incentive prizes on platforms like Topcoder or Kaggle or Crowdflower or other groups like this, do an algorithm competition where we can actually do better than the best NASA algorithm for detecting asteroids, because it's all about machine learning and computer intelligence. And this is something that our group at Planetary Resources would not be able to do by ourselves. But if we open it up to the world, put in place the right incentives, we can really solve a lot of different problems with the billions of brains that are out there, then the wetware is a little bit underutilized.
I gotcha.
Yeah.
Okay. So next question. Do you foresee trying to capture and move an asteroid into a Lagrange point in order to use it as a fueling/mining station? And if so, what's the timeline for that?
Okay, so this is something that NASA is considering. They have a project they're looking at, the Asteroid Retrieval and Redirect Mission. It's an interesting idea, and it all comes down to energy. Think of mining on Earth. You don't often do it whether it's open pit or you're in a mine shaft. You don't often dig all that rubble out and then ship it somewhere halfway across the world and then break it down and refine the stuff. So what you really want to do is do as much of it on site as possible. In our case, when we're going to start, water.
Yep.
We'll use solar energy from the sun, heat up the asteroid material, and just like distilling seawater and removing the salt, we'll heat up that asteroid material, evaporate the water and condense it back out, and bring back, probably 99% pure water to the Earth-Moon system, to the Lagrange points like Michael had mentioned. The timeline for doing this really starts not too far away. We'll be at an asteroid 3-4 years from now. We'll deploy the first extraction demonstration, probably the turn of this decade in the 2020s, and that really sets the pace for this taking off. Yeah. Just a final point on this, we often overpredict the pace of progress in the next year. Yep. Everyone at this conference will make bold claims about what will be possible next year, and they'll probably be mostly right, but they'll fall short, maybe only by 6 months on some of these things. But 10 years out, we've always been totally wrong.
Underpredict that.
We just way underpredict. Yep. And if you think about the evolution of the automotive industry from the gas pedal in your accelerator, and then someone got bored of holding their foot there, so they created the cruise control, and then people started running into the backs of other cars. So now we added radar into that, but that only happened relatively recently. And then, only within the last 5 years, now we have Google self-driving cars licensed to drive in the state of Nevada.
Right.
And I doubt that anyone on the planet, except maybe Larry and Sergey, would have predicted that 10 years ago.
Right.
So 10 years from now, we'll be ready to take on these challenges, and I don't know, it's going to be fun.
Yeah, for sure. To get a little more specific about the question, we're on the same path. We want the same water. We want the same materials, minerals. We're getting them from different sources, but ultimately, I believe the Lagrange point is kind of key to everything. Is that your philosophy?
It's the crossroads of space.
It really is. Once you get to the Lagrange point, which by the way is energetically very easy, it's easier to get to the Lagrange point. So when you go to low Earth orbit, that's really hard. That was the video we showed earlier. We do most of our activity going from low Earth orbit to geosynchronous orbit, and very, very little going to Mars, and in the last 40 years, almost none going to the Moon. What we have looked at is it's less energy going from from low Earth orbit to Lagrange than it is to GEO, even though it's significantly further. So that becomes kind of this outpost. That becomes the beachhead that we can use to expand everywhere else that we want to go. And so
it's kind of like the saddle between two peaks on a mountain.
Yeah.
It's hard to climb up the mountain to the left, or you got to climb back down. But in the middle, it's where the base camp is. And we're talking about setting up the base camp in space. And I often use St. Louis as an example. You go back 150 years ago. That was the point at which Lewis and Clark disembarked. They got all their rations. They sent off all their messages to Jefferson. They brought on all the team that they had. But after they left St. Louis and headed west, that was it. Yeah. So we're going to create the St. Louis of space at the Lagrange points.
I'm going to copy that. That's a good analogy. I like that. So yeah, I think we're going to have a lot of stuff. That Lagrange point will be that shipyard of the future when you start thinking about Star Trek and you start thinking about these big infrastructures. We actually refer to it as the lunar space elevator infrastructure. That this is the thing that will have fuel and energy, people, resources. You're going to construct satellites there. You're going to fix other satellites. You're going to refuel satellites. And then if you want to go to the moon, you take our elevator. If you want to go to an asteroid, launching from that point is virtually effortless. If you want to go to Mars, if you want to go to anywhere else, like that's going to be the crossroads that takes us everywhere else to space. And we're going to have a string that basically runs from the moon through the Lagrange point back towards the Earth, and that will stabilize that position. Yeah.
Okay.
Yeah.
Well, that's all the time we have, so thank you, Michael. Thank you, Chris, for joining me. And
you.
stick around, guys. We've got some more speakers coming up, so we'll be back. Thanks.
Great. Thanks.
All right.